Hi everyone, for this lesson I'll show you how to calculate the standard deviation, and the standard deviation is given by this formula. And the standard deviation is a measurement that shows you how much the data values deviate or vary from the mean. We use the symbol sigma, which is a Greek letter, to represent the standard deviation. So sigma is equal to the square root of the summation in parentheses x minus x bar squared over n. So the capital sigma means the sum of a series of numbers. All it is, you just add up all of the numbers. Right? So that's what this capital sigma means. And then we have the x, and that the x is just the value in the data set. Right? And then we have the x bar, and that refers to the mean of the data set, right? Or the average. And then we have n, and n is the number of data values in the data set. Alright, so let's take a look at this example where we have a data set consisting of these 5 numbers: 5, 6, 10, 12, and 15. And I already calculated the mean, which came out to 9.6. So what you want to do is create 3 columns. The first column is just the x values. So all we have to do is write down the 5, the 6, 10, 12, and the 15. Now the next column is to take the x minus the mean. Now the mean is 9.6, so all we have to do is put the 9.6 down here. So 5 minus 9.6, 6 minus 9.6, and so on. Alright, the next thing we want to do after we find the answer to 5 minus 9.6, which comes out to negative 4.6, is to square it. That's what x minus x bar squared means. So let's put a squared here. Alright, so we're referring to this 2, and put a squared here, and so on. Now after squaring each number in this column, we have negative 4.6 squared, which gives us 21.16. Negative 3.6 squared gives us 12.96. All of our answers are positive, and that's what we want. And this capital sigma tells us that we need to add up all of the numbers, right? So if we were to add up all of these numbers, we're going to get 69.2. Alright, the only thing we have left now is to carry out the calculation. So sigma is equal to the square root of capital sigma in parentheses x minus x bar squared over n. We already found the numerator here, right, which is the sum of this column, and it came out to 69.2. So let's plug that in here, 69.2, and the only thing that's left is this n, right? And since we have 5 numbers, so n is going to be 5. So if we were to calculate 69.2 divided by 5, we're going to get 13.84. And if we take the square root of that, it's approximately 3.72. Alright, so that's the standard deviation, 3.72. Alright, so let's recap. We found out that the standard deviation for this data set was 3.72, and the mean was 9.6. So this means that the data values vary from the mean by 3.72, and the 3.72 is just the standard deviation. If you have a low standard deviation, that means most of the numbers will hover around the mean. But if you have a high standard deviation, that means that most of the numbers are not close to the mean. That is, there's more variation in the data set. So in summary, we use this formula to calculate the standard deviation, and the standard deviation is a measurement of variability in the data set. And we're done, and we're happy.